to Test Prep Central. We're working on Calculator Workshop number 6, Regression Equations. Example 1, generate a linear regression equation for these data and find the correlation coefficient. Determine what the equation and the correlation coefficient reveal about these data. The number of spectators and the amount of money in the concessions box at the end of soccer games is given in the table. The attendance is given in the first row of the table, cash in the second. And we're going to enter this data into list 1, list 2 in the calculator. So I'm going to clear my memory, second plus 712. And when I go to stat enter, I have an empty table to put my data in. So let's type our attendance into list 1. You type the number followed by enter, and then it will go to the next line in your table. If you make a typo, you can back up, you can delete, you can type over. So there's really a lot of different things you can do. I'm going to count the numbers in my list. 1, 2, 3, 4, 5, 6, 7. And I do have 7 because this is now on the blank spot on 8. So go to list 2 and type in cash. $61, $86, $74, $142, $60, $111, and $97. Next, we're going to turn on, we're going to go to turn on our stack diagnostics. To do that, go to Mode and scroll down towards the bottom where it says Stat Diagnostics and highlight On and type enter. And now the stat diagnostics are on. The purpose for turning those on is so that you will be able to see a correlation coefficient when you generate your regression equation. All right, to get out of this, let's just go to second mode, and that's your home screen. And let's generate a linear regression equation. The buttons are stat, right to calc, and then 4. And then enter 5 times. And here is our regression equation. The first number listed, that's A, which is your slope. It's about 2.6, and that's telling you that sales increased approximately $2.60 for each additional spectator. The second number listed here is B, and that is the Y-intercept of the line, and it is approximately 22.57, which means the concession stand started with about $22.57 in cash. The last number listed, this R, not the R squared, but the R, is called the correlation coefficient. That number is approximately 0.985 in this case, which is very close to 1. 1 is a perfect fit, so that's telling you that the data and the line work well together. That data is a close fit to this data, to this line according to this correlation coefficient. All right, for example 2, it says to generate a linear regression equation for these data and find the correlation coefficient. Graph the trend line over these data. What does the graph and the correlation coefficient reveal about these data? So I'm going to go back to stat enter. In list 1, I'm going to type in the numbers. Now this time, to do something different, I'm just going to type over the numbers that are here. So I'm going to type the 21 enter and see how that replaces the number that was there from the prior example. You may also clear your memory, which will clear all lists, or clear each list individually, whichever you prefer. This list is just a little bit longer than the prior list. So you'll notice it says 10 here. That means I'm on line 10, and that means there's 9 points above. So I'll count my numbers, and I do have 9 values in next to the X. So that is correct. So I'm going to go to list 2. And to do something different, I will just clear this list. So let's type clear, enter, and then start with a clean list and type in our Y values. There are other options for entering data that you may have heard of. One of them is to copy the data with the list menu. You can actually hook up your calculators with cables and transfer data from one to another. We're not doing that in this workshop, but if you are interested in doing this with your students, if a teacher maybe want to copy the data to all the calculators, it does save some time, because this is probably the worst part of doing data analysis, is having to actually enter the data. All right, I've entered all the data for list 1 and list 2. So now let's go out to second mode and let's generate a linear regression equation. So I'm going to type stat calc 4 and then enter 5 times. And this will generate my linear regression equation. All right, so notice that the A and the B, the slope and the Y-intercept are given, and the R value is really tiny this time. So the correlation coefficient is almost 0, which means there's almost no linear association between the variables X and Y in this case. So let's graph and see what this looks like. If you'll go to your window, adjust the values to fit this problem. I'm going to start at 0 and go to 25. Notice your X-min should be lower than your lowest X value, and your X max should be higher than your highest X value. If I'm going from 0 to 25, a scale of 5 is appropriate. For the Y-min, let's choose the same thing, 0 to 25, Y scale of 5. All right, now to see data that's in a table, you must turn on your stat plot. So let's type second Y equals, enter, enter, and now the plot is on. So when I type graph, I should see a plot. Now I have not typed the regression equation yet, so let's do that. Let's go to the Y equals, and we're going to copy and paste the regression equation into our Y equals. So to do that, press the button that says VARS, V-A-R-S, and then press the right arrow to highlight Y VARS, which is Y variables, and then type 1 for function, and then 1 for Y1. Oh, excuse me. I did that completely wrong. Let's try this again. Let's type variables, and then a 5, because I don't have anything in Y1, of course, and then EQ, so you'll go right twice, and then 1. And this is now that regression equation that you saw on your screen. It just pastes all those digits. It doesn't round anything off. This is very helpful, because sometimes you don't want to have to write down and then try to type in all that. So let's type graph, and it will graph this line over the data points. And it doesn't really touch the data points. It's kind of close to 1 point. It is not a good representation of that data set. So that equation, or that trend line, is showing you this data is basically not linear. All right, let's move on to the next example. It says to generate a regression equation and a quadratic regression equation for these data. So let's go back to stat, enter. Now both lists are completely different, so I'm going to go ahead and clear my list this time. And if you'll start in list 1, we're going to type in the X values, -3, -2, -1, 0, 1, 2, 3. And then in list 2, we're going to type in the Y values that appear. I don't know if these are Y's or not, because we don't really have any variable here. It's just list 2. And from my experience, students are much faster at doing this than adults for some reason. I don't know. I tend to go slower than my students when I'm typing in data. I guess they've grown up with the technology. Okay, so what we're going to do now is we're going to generate a linear regression equation for these data. So let's go to second mode and type stat calc 4 and then enter 5 times. This is the most common regression equation that we use, is a linear regression. Now we're going to take this equation, we're going to paste it into y equals for y1. So I'm going to clear what's already here. And to paste that, I'm going to type variables, then a 5, yeah, don't do y variables, then EQ, so go right twice to EQ, and then do 1. And that is pasted the linear regression equation. Now go back out, second mode, and let's generate another regression equation for the same data. So we're going to type stat calc. And this time, instead of 4, I'm going to choose 5 for quadratic regression. And then we're going to type enter. Okay, now you'll notice that the correlation coefficient is not showing up. That's because it only is valid for linear equations. So we won't see an R value for the nonlinear equations. All right, this is a quadratic equation. So I'm going to take this equation and put it in Y2. So go to your Y equals, arrow down to your Y2, and let's paste that one into Y2. So we're going to type variables and then 5, which is statistics. Go right to EQ and then type 1. And it's pasted all those numbers in there. It doesn't round them all. All right, now I do already have my stat plot turned on, but you can go back in and look if you want to. Second Y equals, enter, enter. It's the same data. It's the same plot, so this is on. Let's adjust the window to fit these data. So this time, my lowest x was -3. So for my window, let's use -5 for our x-min. Our highest x was +3. So I'm going to use a +5. And I'm going to count by ones because those numbers are small. Now for the y minimum, the lowest y was 0. So you may want to go to -1 to go a little to the left of that. Or actually, let's see, in the handout I chose a -5. So I'll be consistent and use that. And then for the y max, I'll choose a 10. These numbers are also relatively close together. So I'll use a 1 for the scale. Now when you type graph, it's going to graph the data that you already had in there. And it's going to type in the line. And here is the quadratic. This is the regression equation, the quadratic regression. So of the two models, clearly the quadratic equation is a much better fit to these data. Let's move on to example number 4. Generate a linear and a quadratic regression equation for these data. Determine the correlation coefficient for the linear model. Graph both equations over the data and which model seems to fit best. Well, I don't know if you recall, but in the last example, our correlation coefficient for our linear model was really low, so it was not a good fit. Let's see if this one's any better. If we go to stat enter, you'll notice that the list 1 values are the same, so all we really need to change are the list 2 values. So let's type 10, enter, 6, 6.5, and then 2.5, 1.5, 0, and -1. Okay, so to get our linear regression equation, I'm going to go to second mode, and I'm going to generate that equation. So we'll do stat calc 4 for linear, and then enter 5 times. All right, so notice the correlation coefficient here is excellent, 0.97. This means it's really should be a good fit. Now let's go in here and clear out both of these equations. Well, I can't seem to get on the row, guys. I'm sorry. All right. To put the regression equation in Y1, type variables, 5, go right twice to EQ and type 1. And now you have your regression equation there. So now we're going to go to Y2. We'll do that in a second though. Let's go to second mode to get out and type stat calc. Quadratic is 5. Not 4, but 5. We're still using list 1 and 2. And now we have our quadratic model. Now we don't have an R value. We have an R squared value, which is really close to 1, which by the way is also a good thing. So this one is going to fit probably fairly well as also. So let's go to Y equals, and we're on Y2 now. So we need to go down one row. And let's paste that equation into Y2. So we'll do variables, statistics, EQ 1. All right, so now we have both equations typed in. Let's adjust our window to fit these data. I think it's going to fit just fine though. Let's see. Our X values are fine. The Y value says it needs to go to 10, so I probably should change my Y max. Yeah, I don't think I did change. Oh, I did change it. I changed it to a 15 in your handout, so that's a good idea. The others look great, so we're not going to change any of that. Let's go ahead and type graph. And you may notice that these data points are all fairly close to the line. They're all fairly close to this curve. So really, both models fit this data well. Both regression equations would be appropriate as far as we know. We don't really know where this data came from, so we don't know much else about it. So without any further information, it would be hard to choose one over the other. Both models are excellent fits to the data. In a later workshop, we'll learn how to calculate and analyze residuals for graphs, which will maybe help us determine a better model. But for this particular example, we don't have enough information to pick one model over the other. Be sure to read the helpful hints, and don't forget that practice makes perfect. So the more you practice the graphing calculator, the easier it gets. Until we meet again, practice, practice, practice.